Hi everyone. Today we're going to start learning how to do something called factoring. And eventually we want to work up to the point where we can factor a quadratic. But we're going to go nice and slow. We're going to go one piece at a time. And the first step has to do with what's called the greatest common factor, or sometimes we abbreviate it GCF. And that's when you're factoring, but just with numbers. There's no x's or anything like that. We're just talking about factoring out common terms from numbers. So first of all, let's start with that word factor. A factor is a number that divides evenly into the number that you're working with. So for example, 2 is a factor of 8 because 8 divided by 2 is 4. And that's what I mean by divide evenly. When you divide, you get a nice whole number answer. And then I said, but 3 is not a factor of 8 because 8 divided by 3 is not a whole number. It comes out to like 2.66 repeating. So a good way, if you're trying to find all the factors of a number, a good way to do it is by pairs, by thinking of two numbers that multiply together, and each one of those numbers is a factor. So for example, I said 8 divided by 2 is 4. Well, another way to think of that is 2 times 4 is 8. And that means 2 and 4 are both factors of 8. So let's list all the factors of 24. And I'm going to do it by pairs, like we just talked about. I'm going to take my number 24, and I'm going to create what we call a factor tree. And I'm going to list all the pairs of numbers that multiply together to give you a 24. Now the first one I always think of is 1, because 1 times any number equals that number. So I'm going to start with 1 times 24, and then we'll try 2. You say, okay, well, is 2 a factor of 24? Yeah, it is, because 2 times 12 is 24. And then we say, how about 3? Yeah, that one works too. 3 times 8 is 24. And then you say, how about 4? Yeah, that one actually works also. 4 times 6 is 24. And then you say, how about 5? And there's our first one that doesn't work. 24 divided by 5 would not be a whole number, so it does not work. And then the next number is 6, but if you look, 6 is already on our list because we have 4 times 6. And that's when you know you can stop. When you're working through your numbers, 1, 2, 3, 4, 5, 6, as soon as you get to a number or past a number that's already on your list, then you know you can stop. There are no more pairs. So basically, all 8 of these numbers are factors of 24. So the answer to the question, just list them. I like to go in order. So the answer to the question is 1, 2, 3, 4, 6, 8, 12, and 24. Those are all of the numbers that divide evenly into 24, meaning if I do 24 divided by any of those numbers on the list, the answer will be a whole number. If I do 24 divided by any number not on that list, it won't give you a whole number. I'll get like a decimal or a fraction. And that's what we mean when we're looking for factors of a number. Now that leads into the title of our section today, which was greatest common factor. And a greatest common factor is when you have more than one number. If you have a group of numbers, it might just be 2, it might be 3 or 5 or 10 numbers, but you have this group of numbers and you want to find the biggest number that is a factor of all of them. And that's really where the name comes from. If you think about it, greatest means biggest. Factoring is what we're talking about, and the word common means the same or shared. So common factor means it's a factor of all the numbers in the group. And we're looking for the biggest one. So let's find the greatest common factor of 18 and 27. Now what I'm going to do is I'm going to do a factor tree for both of those numbers. Let's just do it separately. Let's start with the 18. And let's do the same thing we just did with 24. I always start with 1. 1 times 18 is 18. And then I think about 2. Yeah, 2 works. 2 times 9 is 18. And then I think about 3. That works. 3 times 6 is 18. And then I think about 4. That doesn't work. 18 divided by 4 is not a whole number. Or 5. And then I get to 6, which is already on my list, so I'm done. So those are the factors of 18 and 27 of 18. Now let's do the same thing for 27. I'm going to start with 1 times 27, because I always start with 1 times the number. Not 2. 27 divided by 2 is not a whole number. 3 does work. We have 3 times 9. Not 4, not 5, not 6, not 7, not 8, and then we're back to 9. So we're done. So 18 has 6 factors. 1, 2, 3, 6, 9, and 18. And 27 has 4 factors. 1, 3, 9, and 27. What we are looking for is the greatest, meaning the biggest, common factor. The biggest number that is in both lists. And that answer is going to be 9. The biggest number that we see in both lists is 9. So for 18 and 27, I would say the GCF, that's the abbreviation we're going to use for greatest common factors, is 9. All right, let's do one more example because I want to show you what happens when there are 3 numbers. So now we're going to do the greatest common factor of 16, 20, and 26. So I'm going to start off by doing 3 different factor trees. Let's do the 16 first. We have 1 times 16, definitely, always start with 1. 2 works, 2 times 8 is 16. 3 does not work. 4 works, 4 times 4. And that's the end of our list, because once you hit the same number again, 4 worked and it's on both sides, we're done. 5 doesn't work, 6 doesn't work, nothing else will work. All right, let's try the 20. We have 1 times 20 for sure. We have 2 times 10, not 3. We have 4 times 5, and then we're done because we just got the 5. Okay, now we can't answer the question yet. If we were just doing the greatest common factor of 16 and 20, it looks like the answer would be 4. But we're not done because we don't know about the 26. So let's do the 26 also. 26 could be 1 times 26. It could be 2 times 13. And that's actually going to end up being it. 3 does not work. 4, 5, 6, 7, 8, 9, 10, 11, 12. None of those work. And then you're back to 13. So what I want to do, see, the answer to this question is not 4. It's not saying the greatest common factor that's from 2 of them. It has to be common to all 3. Now, the biggest number that I see that is in all 3 of these lists is 2. There's no number on any list that's bigger than 2 that is on all 3 lists. So make sure you understand when you're doing greatest common factor, it's not just between 2 numbers. It's between all the numbers you're being asked at. You make that factor list, and then you find the biggest number that is in every single list. So the answer to this question, our greatest common factor of these 3 numbers would be 2.